Cool.
Hello, everyone, and welcome to the Kubernetes Navigating the Seas of Deployment Without Syncing Your Application webinar. Um, Gui Martins is here, and he's going to be your captain over this voyage. Did you like that?
Yeah, that's good. Yeah.
Guy is a senior consultant, and he's been working with Centrilogic for a long time. A great expertise on Kubernetes, and I'll let him introduce himself in a minute. My name is Ricardo Cobo, and I'm a principal consultant on the app dev and modernization. And I'll be here basically to moderate. If you have questions, throw it on the chat. I'll make sure that they get to Guy. Uh, and a little bit of about Centrilogic. Centrilogic is a company that's sponsoring this webinar. We've been in business for 15 plus years. A lot of focus on Microsoft technologies. Guy and I work on the business group that is centered about Microsoft, Azure, and modernization of applications. We have very senior consultants, mostly located here in Canada, um, and we've been working with Microsoft in very tightly. We have several designations in as a partner. Some of those are really the specialist ones are really difficult to get, but we manage. We do delivery across North America and Europe. So we have a footprint. Centrilogic is headquartered here in Canada, but we also do business in the United States and in Europe. We can help with anything from creating landing zones to modernizing apps, all the way to managed services. So please feel free to reach out if you have any any needs, any requirements. And that is all the marketing I'm gonna do. So now to the real content. Take it away, Guy.
Cool. Thanks, Ricardo. Let me see if I can share my screen, but I'll talk in the meanwhile. So, pleasure to meet you. Ahoy. So, name is Gui Martins. As Ricardo said, I've been working with Centrilogic and doing Kubernetes for, you know, a long time. So ever since the first few versions of Kubernetes, and bear with me while Teams allows me to share something here, and it doesn't. Do you know what? I might have to rejoin. I'm so sorry about that. Give me a quick second. I'm sorry.
All right. I do want to say that we did do a test before this. You're just unlucky that something happened there with the setup. So we'll wait for Guy. Welcome back, Guy.
Yeah, thank you. Let's see if that goes and share. There we go. All right, better.
There you go.
Sorry about that. Teams is a little bit, I won't say anything. So, as I was saying, so I've been doing Kubernetes for quite a while, containerization, even before Kubernetes was a thing. And what I do is mostly help people to deploy and make sure their applications don't sync in the seas of deployment. So I know it sounds funny, but it is very much true. And probably you are here, you understand that whenever you deploy things and somewhere, be that cloud, on-prem, your Raspberry Pi, deployment is something that usually gets you. You can have your application running your machine, and the old saying of "but it runs on my machine," and this is why Kubernetes is a thing. This is why containers are a thing. And today, this is the second time that I'm doing this webinar. Today, I'm going to try to explain why it is so great to use Kubernetes, containers, and hopefully share something that helps you get the extra mile there, get your application up and running. Even if it is, hey, this is a technology, this is how you use it, have fun trying to use that, and we're going to get there. So anyways, navigating the seas of deployment. As I said, we're going to just talk about what are containers, what is Kubernetes, and the details of why you should use it, and what is the real power of it. And don't worry, it's not going to be only slides. I'm not a guy that likes to do lots of slides. I want to show you things. So, what is a container? And don't mind the AI generated container image there. I just found that very fun. Containers are just layer static, distributable, small chunks of images. So I know it's not live, but usually I would say show of hands of how many people here has used a image before, right? Be that a container image, be that a file image, be that VM image, right? A machine image, right? So you would use back in the day a ghosty image that you would, package everything that you want in it, a VMware image. Containers are not that different from it. The idea here is you build a layered version of your file system that would have everything that you need to run your application. Now, hey Guy, but can't I have everything that I want in that image? Yes, you can. Containers are made to be, just a container. I'm saying containers too much of what you want to run, right? In a repeatable manner. But what is special about that is that containers, they contain that on top of the operational system layer. So how does that work? In the world of virtual machines, you separate your resources and you tell the hypervisor of your machine, hey, I want 2 CPUs to go here and I want 2 CPUs to go here. Then, half of my RAM here, half of my RAM here, and that's it, right? You cannot access more RAM if your service is starving in VM1 and VM2 has it available. That's not how it works because you're separating at the hardware level. Now, when we're talking containers here, you actually have the your machine running with your operational system, your drivers, right? So everything that translates your communication with your hardware, but it's on top of that, right? And you put your containers on top of that operational system, right? And then you translate all of those calls to your operational system, which means you can scale as much as your application want. Now, if you're paying attention to what I said, that can lead into some starvation of resources and all that. And this is where it gets you. It's very simple, but you have to understand how it works. So you don't just deploy, 20 services into the same VM and it doesn't fit there and then it scale and then just get out of memory. But regardless, it is a simpler way to run everything. And because all of the drivers and all of the communications and all the translation layers and the shims that actually translate to your hardware are already implemented into your operational system that your containers run on top of, your images can be very small. So if you just need a container that runs a web server, you don't have to implement your network driver. You don't have to implement your file system. You don't have to implement any of that. You just say, hey, this is my web server binary. These are my files that I want you to expose, and then run this and expose on port 80. And that's how it goes. Anyways, containers. So this is not about containers, but it's very important to have this level set of containers so you understand why Kubernetes is so important. This is all great. But what is Kubernetes then? Well, it's just a container orchestrator. Simple, eh? So think about that. You have now a container that you packaged and you have your web server running, but it only runs in one machine. What if I want that to run in multiple machines? What if I want to clusterize that? What if I want to run my enterprise level? I'm calling web server, but it can be your database. It can be your API backend, your middleware, anything really. How do I control that? Because you're not going to be running that in one machine. What if you have to, take that down to upgrade your operational system? Are you going to expect downtime? No, you're not. So you need an orchestrator to orchestrate all of those operations. And this is what Kubernetes is. But what it really is a platform for managing those containerized workloads. Is it just another word for orchestrator? Yes, it is. But there's more to it. So the idea of Kubernetes is it is an API aggregator. So think of about that. When you create a platform, and I like to think about Kubernetes not only as an orchestrator, but maybe a platform and a base for your platform as well. It is a set of definitions of APIs that manage containers, the networking bits of it, the control of security, the storage, everything around containers that operationalize them in a way that you can actually go to production faster and easier. So because it is made in such a way, you can have, and because it is open source as well, you can have a multitude of flavors. I call flavors, distributions, right? Same way as you would have Linux. Many companies and many communities have came up with their own flavor of Kubernetes. You would have AKS, OpenShift, EKS. So AKS is Microsoft's that runs on their cloud. OpenShift is the Red Hat one. EKS from AWS, K3S from Rancher, and this one is really cool because you can install in bare metals. NicoKS from Canonical. Anyways, many companies have done their own version, their own flavor of Kubernetes, which essentially work the same way. You want a container, you deploy it, you get one. You want to expose it, you get a way to expose it. You want to extend that and create more APIs to control the resources. It is there. The definition, so the standard, the schema of how Kubernetes works, it is compatible. That is not to say each one of those has different and better or worse, just different features. So it is important to understand that. It is the same idea as choosing a Linux distribution or a cloud provider. It is a platform in which you're going to implement and use your applications or your workloads. It is just that it might be different in the way that you're going to do that. So same way, you have Windows, you're going to have your Microsoft Office. You have Linux, you're going to have your LibreOffice. But they're essentially the same thing. Where was I? Yeah. So anyways, this is the idea, right? So it's open source, it's extendable, portable. You have this aggregation of APIs. Okay, Guy, cool. Now I understand how that goes. How does that work really? How do I use that? Oh, sorry, before that, my bad. But why should you use it? Given all of that I just said, you have the flexibility to deploy anything that you want in any way you want. It's a daunting task though, because now that you have all of this and it's so extensible and it's the same everywhere, you can pick and choose all the pieces that you want, create new pieces of abstraction, and deploy it anywhere you want. So it is so powerful that, and this is what I tell all of our clients, and this is what I tell everybody, where we should get at is you should be able to deploy to AKS in Azure, and then if something happens, you'll have an on-prem cluster running a different distribution of Kubernetes, and then you have another cloud provider running at the same time, and it all should work the same. This is the power that you get with Kubernetes, and you shouldn't feel a difference between those. This is how powerful this is. By the way, I'm going to share these slides here later because I have some links just so you can follow in and understand what I'm talking about. Any questions so far? Because I'm going to move forward. No? Okay. Cool. Alrighty. So what I'll do here is, can we move container to Azure to AWS? So moving containers is something a little complicated. You can deploy your container to AWS and Azure. Now, moving containers, that's complicated. Containers are by nature ephemeral. So you should be able to just create a container, delete it, and get a new one, and things are just going to work the same. If you want to move something, it means that you're going to move the data maybe of those, and you can have layers of distribution of data that will work the same regardless of where you are. So you have CIFS, you have even some NFS file shares. And what you can do is have two containers pointing to the same NFS share, and then suddenly they just work the same. Doesn't matter where you go. So you knock one off, get a new one, knock one off, get a new one. Doesn't matter which cloud you are, they're going to be up and running at the same time. I'm oversimplifying here. Bear that in mind. But with the nature of containers, you should be able to do that. Yes.
Yeah, I would like to add that it's a very open question. So your container, so there is two type of, so you can have your container run on Windows or Linux, and if you have certain Windows specific requirements, you could still deploy it on AWS, but your underlying technology needs to be Windows. So it's just as Guy said, like that. The theory is that you get an image and you can deploy it anywhere, but that you need to be aware of certain conditions, right? It's not.
You got it.
Is yeah.
That's perfect. Thank you, Ricardo. This is a callback to exactly this here. Remember your flavor. In Azure, you're going to get AKS. In AWS, you're going to get EKS. And maybe your operators are going to be different. Maybe your infrastructure of volumes and container runtimes is going to be different. Just you have to be aware of those and solve for those differences before you are fully, able to quote move or be active between those containers. But it's a good question because you want to move, right? Given that it's small. Cool. Yeah, anytime. So what does it look like? Kubernetes, there's no real picture to show this, right? So what it usually looks like, it's a YAML file. Now, does it have to be a YAML file? Can it be a JSON file? Can it be API calls? Definitely. But as a whole, the community of Kubernetes uses YAML files, right? So the friendlier and human-readable version of JSON to define what their resources are going to be requested are going to look like. In Kubernetes also, we call the minimum unit of compute a pod, which is essentially a tightly coupled, context-aware set of containers. Translating, this is just a wrapper in which you put your container or set of containers in, and you give some metadata so Kubernetes understands what to do with that. How does that work? You ask Kubernetes, hey, communicate with the V1 API of Kubernetes. And see, V1 here means this is the standard API of Kubernetes. You don't have to route that into any different API inside of Kubernetes. Call the pod endpoint. It's just kind, right? So it's going to be api.kubernetes.com. I'm just using a random endpoint / v1 for the API version / pod, and then you're going to post or patch or put. So the verbs of the HTTP requests here are very important in Kubernetes. If you want, I can go a little bit more in detail of that, but you just call that out and say, hey, define for me a pod with the version v1 of this API of Kubernetes. And then you tell Kubernetes, this is the metadata of what you should be aware about this pod. So you give it a name, you give it a namespace, an annotation, which is just a key value set, and labels, which is also a key value set, a dictionary really, but labels are used for selections. Those are going to be important later. Namespaces, before I go on. Namespaces are just folders of Kubernetes. So it's a logical subset of where you can put your resources. So you can have namespaced resources, such as pods, such as volumes, such as things that would be dedicated to a domain, a project. Depends on your nomenclature or how you define your platform. But essentially, this is a way to segregate resources so they don't all just fit in the same place. Annotations can be used for the APIs to understand what to do or what this is about, or for a human to read and understand what the resource is about. And labels are just logical labels that can be used for Kubernetes or on any other operator to do something. Anyways, just metadata. This is not doing anything essentially. This is just telling Kubernetes what to store about this pod. And then you have a spec. The spec here is now defining exactly what this pod and how it should be running and how the pod API should do things. And this is how it works. You say, hey, pod of Kubernetes, I want you to run a container of name nginx with the image nginx latest. And it can be any registry here, really. So I'm just pulling from Docker Hub. And I want you to run and expose Docker, the port 80 to the cluster inside of that namespace. And that's it. You tell that, you push that via a HTTP request to the cluster, and Kubernetes is going to do the rest. That's essentially how it goes. Let me show you one. So I'm going to just pull up a terminal here. I am in a namespace. All I'm using here is I have a bunch of aliases that actually shows the pods here. And what I'm saying here, I want to show the pods that I've deployed into this is my personal Kubernetes cluster running K3s as the version, and this is the namespace. So I have, let's say, these pods here, and essentially, if you look at that, let's get this pod here. You're going to see that I have, as I said, the metadata here, as well as the container definition here with an image, some environment variables, and then some status conditions here. This is just a fancy terminal that I'm using, but you can also just grab, get pods, grab, oops, sorry, kubectl, get pods, and then not this guy. Sheesh. One sec. All right. All right. So the same idea here, right? So as I've shown you there, you can have all of this. You have your metadata here, and you have your spec of the container, and you have some very cool things. And I'm not afraid to show you this. This is a running application I can show you later, is that you can even have what's called secrets that just essentially keep things, sanitizes things. So this is just an open running container. But as you can see, it's just a spec that has a container, a port in which it runs, so it is exposed to the local namespace. Mind you, local namespace, and it's just for this pod. I'm going to get to the details of it. And you have, where it's running, so which of my nodes is running this. So as you can see, you can have many nodes running here. So I have in my cluster, I have a total of 10 nodes. And now, and because I asked it to run, it just runs somewhere, and I don't have to worry about where. Remember, this is a cluster of containerized workloads, so it's an orchestrator. I don't care where it runs, really. It just does it. Anyways, it's defined here. Now, you're going to see here from this pod that it has not only a name for it, but also a bunch of IDs. What are those? So you don't want to deploy things just once, right? And this is what's important to understand about Kubernetes. If you deploy a container and you delete it, aren't you going to lose it later? So let me do that example for you. So what I'm going to do, I'm going to copy that. I'm going to do, actually, you know what? I think I have a pod here. Yeah, there we go. So it's just an example here. Same thing, right? Let's do that. So sample pod. There we go. So you're going to see now we have the Nginx pod. I just said, hey, deploy this Nginx pod with this definition, with this metadata in the same namespace that I am. So that's why it came to this namespace. I just didn't tell the API. So the API assumes via my context that I'm here. Through my kubectl. Sorry, I'm using aliases, but kubectl apply -f, which is calf here for me, and kgp kubectl get pods, right? Same thing. And it just created it, right? So now I have this nginx pod. And if I get the cl get pods nginx definition of this pod, it's going to have a bunch of status to show us what is up with that, and also, the volumes and things that Kubernetes enriched via their operators about this. But essentially, it's just the pod that we've deployed. But now, if we delete pod nginx, it's gone. And this is why you don't want to do that. Because you see, this is my up and running application, quote, production. If I delete that, and now let me just do this. So here, these are my pods, and I'm going to delete my pod of craft. See what happens? It terminated, and I have a new one up and running. And because I had two, my load balancer didn't have to do anything. It just dropped the endpoint of the one that terminated, and it got a new one. So let me just refresh here so you can actually see what I mean. I have two up and running, one for 17 seconds, the other one for 6 days. This is how powerful that is, right? I don't care if my pod gets deleted. My data is in a database somewhere else, and I always have a few replicas running. How do I do that? To do that, and I just saw the time. I'm sorry, I'm derailing a little bit, but it's important. You use what is called an extension of pods that's called deployments. Fun story, this used to be a community-driven extension/operator that was a API that implemented this replica controller for pods. And it's now adopted into the API of Kubernetes directly. So every single Kubernetes, it doesn't matter the flavor you choose, is going to have a deployment. And the same idea here, right? So you call the API v1 endpoint with a deployment type. You call some metadata. Metadata is always going to be the same. And you just tell it, hey, I want one replica of this always running. I want you to control it by using these labels. So you tell the deployment, hey, it is your pod because it has those labels running in this namespace. And this is and then you create a template of what that pod should look like. So then instead of just deploying that one pod and if it deletes, it's gone, now you have this replica controller that is always up and running that checks the liveness and the readiness of these pods and gets a new one with this template if something happens. And this is, and I hope you start to see the power of this, right? This was an extension, and you can create those yourself. Okay. So let me show you how that looks. So if I go here, I show you the pods here, right? So you have craft here. And if you go to deployments, you're going to see that I have this craft deployment. And it has 2 out of 2 ready, 2 are up to date, and 2 available. So it understands what is going on here. And if I go in here and the way that this works, right? Let's go here and craft. It just enriches the same way as I've shown you before here with a template, right? So this is the deployment. Let me just show you the actual deployments, craft, YAML. All that it is what I was showing you before, right? So this is the metadata, the API v1 deployment, and then you say, hey, I want 2 replicas all at the same time. The progress deadline in seconds, so it takes 600 seconds to understand if to give a deadline for the pod to come up or not. There's a strategy for upgrades. So the max surge. So if I have 22 replicas, I wanted to have only 25% more than 2 when I'm upgrading, and I can never have 25% unavailable. So the controller is going to understand that, right? So it's going to let you know, hey, this is not right, I'm going to get a new pod, or hey, this is too much, I'm going to delete one pod. So it's going to control that for you automatically. And you're going to see Well, where is the but how do I get these numbers here? So let's look at that. So the sorry, yeah, here. So where do I get these numbers, right? The 7F.
Guy, before you move, sorry, there is a question about are these pod replica store in master API server even if we delete the pod?
Okay, so the data, right? It depends. So here's how it works. If you're talking about solely pods, as I showed you, delete the pod is gone, right? Now, if it is gone, it can be that it's not truly gone until it is cleaned up. So it depends on the implementation of the flavor of Kubernetes. So this can get very detailed, but think about this. The master nodes, they have a etcd database. That database is where all of these definitions of YAML files are stored. And when you call, hey, delete this pod, if it is not controlled by any replica sets or deployments or anything else, and it's not going to get a new one, then Kubernetes is going to first call the node and in the API of the node, that is running this pod, and say, hey, delete this container and all of the data that he has. And then he's going to annotate that to say, hey, I am deleting that. And now the state is drifted. So it's still stored in the etcd database saying, hey, I am deleting this. But it can be, depending on the API, that it's going to say, hey, I'm terminating, I've terminated. And it can happen that the volume of the pod that it creates in the node is still out there and is still, scheduled for deletion. So it depends on the implementation. But essentially, once that's gone, it's going to be gone from the etcd database. Depending on your settings, you can also have audit settings set in your etcd database, which say, hey, do a retention of the deleted resources for X amount of time. This is not default, by the way. Usually just, nix it and get done with it, but it depends. So just think about that. It's just a database, an application running on top of that. It depends on the flavor implementation of Kubernetes to see what it's going to be done there. So some cloud implementations, they would actually get a backup of those. So let's say you do a mistake, you might have a backup of those. But something like K3S here, you delete, it's gone. Good luck. That's essentially it. Good question, because I haven't actually explained to you how it works. All of this here, you have master nodes which actually run the API of Kubernetes. So that's how it goes. Cool. Yeah, nice. So, and this is what I meant, right? So you have a deployment, and the deployment creates a replica set, which is yet another operator here. And then if I get a replica set here, you're going to see that we have the old version of the replica sets here, which, again, Kazi, thank you for the question. It hasn't been deleted yet. And this is by the definition of the operator in Kubernetes in the etcd here. They say, historically, just keep a few of those replicas in the back here, because what if I want to roll back to an old version, right? While I'm doing the upgrade, hey, it fails. Okay, go back. Don't do this. I don't want to be unavailable. And this is where these numbers come from, right? So when you say the pod here, so this is the name of the deployment, the name of the replica set, and the actual replica of the replica set. If we have a pod or replica in multiple regions like East and Central region, so Kazi, it really depends. Now you're talking about cross-regional deployments of nodes. So have you deployed 2 different clusters in 2 different regions and you're managing 2 different deployments? Or are you deploying 2 different nodes in the same cluster in different regions, and then you're using a operator to know and be aware of those? What I would recommend is think about how you want to see Kubernetes as a platform. You can make it working any way you want. And this is as much powerful as it is complicated.
Dangerous.
Yes. So what I would say is, oh, what happened here? What I would say it is, you can make that work. You have to ask yourself, do I want that? Do I want to have a cluster that it is controlling nodes in the same region or different regions? Or do I want to have multiple clusters that are managed by another API that trickles down? Because then you have, it's a choice you're going to have to make. It's very complicated. Good question. All right, so I've shown you pods, deployments, and then just before, because I know we have only 20 minutes, I'm going to just let you know here, you can do that with services as well. So services is just a construct of Kubernetes of how do I route my resources, my requests to the right pod, right? You define that as a service. For the networking engineers here, for the operators here, you want to read this here as a type of definition of a IP table. That's how it is. So if you define an internal traffic policy as a cluster, it's an IP table, and you can just define that and say, hey, whenever you try to find out the service craft from the fancy craft, that is going to be available in this IP address in this cluster with a name as well, just forward the port 5000 to one of the pods that is running of the deployment. Yeah, that's right. Sorry, I'm just reading the chat here. Kazi was just saying that, yeah, if you remove a pod from a region or not, it depends on your design. Call it a landing zone design as well for a cloud provider. Call it a VM cluster design in VMware. You can do Kubernetes the same way, right? It depends on your design. Cool. So does that make sense here for the IP tables? So the idea here is you say, hey, Kubernetes, get me a service in which I can reach my craft pod or replicas and route everything from port 5000 of this service from a cluster IP address to the port 5000 of one of those pods from the replica set. And this is how you reach it, right? This is how you make your service really available. This is all great, but this is still just an IP address, right? So yeah, okay, I am reaching the cluster and now I have this IP address, but how do we expose this? This is where things get really interesting. I'm going to show you this real quick. So we have something called the Nginx Ingress Controller, something like that, right? So this is an operator. Same as a deployment was an operator once. This is an operator as well. It just implements a way for you to expose a service, but with a load balancer inside of your cluster. So now what happens is you have let me just show you here, Ingress. So I deploy that into my cluster, same as I would deploy a regular application. And now I have this load balancer here. So all this is also a pod, same way as the other one, but now it has something really cool, a Ingress controller pod load balancer. In interest of time, I'm not going to go into details, but essentially think about this. You tell Kubernetes, I need a load balancer, same as you would in a cloud provider. And then depending on the flavor of Kubernetes that you run, if you're in AKS in Azure, you just ask, hey, give me a load balancer, and then route to this pod running in my cluster. And then what it's going to do is just going to get you, it's going to use the implementation of that operator and get you a load balancer. So if you're in Azure, it's going to get you an Azure load balancer. If you're in AWS, it's going to get a load balancer in AWS. If it is a local cluster like K2S that I have here, it's going to use the BGP protocol to actually create a new bind in my gateway. This is how it's done. So in here I have a gateway / firewall that takes care of that. I just implemented and this is where it gets the powerfulness of this, right? I implemented a controller that knows how to do BGP routing, and then it just grabs me from an IP pool for load balancers of my Kubernetes cluster. And this is how it goes. And then it feeds that to this Nginx controller. And given that this is a operator now, let's go back to my namespace for FancyCraft. All I'm just doing here, I'm just changing namespaces. Think about folders. And I can actually say, hey, give me my Ingress. And now you can see that I have an Ingress that is implemented with that API version. So let me show you how that actually works. kubectl get Ingress. Same idea, right? But instead of using the cluster API, it kind of does. It routes to this definition of this operator API. And it just says, hey, I want these Ingress type, give you a label the same way as you would, the metadata is the same way as you would. But now you say to this API, hey, I want this host name, whenever it's redirected to that IP address of my load balancer, to be routed to my service in the backend in the port 5000. So that's how this name gets routed to my cluster. So this is hitting directly that cluster. See what I mean? This is just an app that I created before. It's one of my demos of AI. So what I've done, I've created a mixture of resources via AI. I can show you that in a different webinar or in another time. But essentially, this is up and running here in that craft namespace. And it's exposed via this name with this secret of certificate, which is also managed by another operator that is the cert manager that manages my certificates and then applies them to the front end of my ingresses. Can you guys see how powerful this is? All in YAML files, I've defined how I want to route things, how I want them to be exposed privately and publicly, how I want them to use a certificate, how I want them to manage that certificate for me, and even better, I even have an operator here. Let me see. I don't use that here. Sorry. Let's see. I think I have. Bear with me for a second. Okay. Let's say I have a. That's a lot of stuff here. Sorry. Let's see. This is my game server for Factorio. Great name. Great game, by the way. If you want any suggestions of games, I definitely say that. So you can even have an operator like Longhorn here, which says, hey, I want in CIFS. You define this here in your YAML file. And then what it's going to do, hey, grab me a disk volume that is going to be available in 3 different nodes of my cluster. That it's going to be always available. And then if one of my nodes dies, I never lose the data. So the data is even high available, and it's all defined by YAML, right? To do that, it is kind of expensive in resources because I do have to run the system of Longhorn itself, and as you can see, it's a lot of operators, so it's a massive application that manages it, and it uses a lot of resources, right? So we're talking about here, report in S. We're talking about here 18 gigs of RAM just to manage my storage. And we're talking about 1.6 CPU to do that. So it is an expensive type of operation, but it is possible. And because of that, I don't have to worry about one of my nodes dying. I don't have to worry about anything. Things are just available. And I hope that you now understand how powerful Kubernetes is and how much you can do with it. And if you want to take one thing away from this, is that if you if you don't want to sync while you deploy your applications, you have to build a sturdy boat. Kubernetes, it's a nice whole, but you still have to understand how to operate it. You need a captain. You need, the seamen. You need people to operate that properly, and you need to understand how that goes. But trust me, once you understand and use that, as you can see here, you're going to be able to run a lot of stuff. I, by myself, run a lot of things, and they're all available. As you can see here, I have, this service that it runs here. I have a AI service that runs here as well. I have my own management system for my own backups, for all my own cloud, my own photos, the whole shebang. And this is all that I do just personally. The things that I do for the clients that we have as well, it can scale quite wide and far. So I'll leave open now for the last 9 minutes if you guys want to have any questions, want me to show something. I just want to, be mindful of your time. If not, I can show you some cool stuff. Cool. All right. So here's what I'm going to do. Okay, Guy, how do you deploy stuff, right? How do you do craft and the whole shebang here, right? Let me show you here. So this is what I do for deploying craft. I don't know if you can see here, but this is a repository in which I define my resources. And look how cool that is. I have a operator that is part of the Flux CD operator. If you don't know, Flux it's a Git repository GitOps operator. GitOps operator, my goodness. So what it does is just checks for a Helm repository, which is also another piece of operator in Kubernetes. It uses that version of it, and then it just defines in here all of the resources to deploy a Helm chart. But Guy, what is a Helm chart? Glad you asked. A Helm chart is a layer of abstraction of how you deploy your applications. So this is open source here. If you want, I can share the link of it. All that is just a bunch of templates with mustache or Golang templates, whatever you want to call them, many names for this. It's just that I've simplified defining the deployments, defining the ingresses, defining the persistent volumes, the roles, the services, yada, yada, yada. So it gives me the power to just define the spec/values of this application like this, and the rest is done for me. It's so much easier to deploy, right? Gets to a point that in 30, let's see, so in 30 lines, I can define the whole deployment of an application that is highly available. This is how powerful it gets, right? And the secrets, look at how cool that is. And the secrets here, they're also using an operator that knows how to authenticate with a backend. That can be a key vault, that can be a key list, that can be any secret provider, right? Secret manager. And it just injects that down here. So not even my secrets are exposed. And indeed, they're not in my Git repo as well. And they're all there. And it gets even more powerful because now these are just files. And I can use something like Renovate, which is a dependency update manager that keeps things up to date like this. So as you can see here, it just checks, hey, there's an upgrade to your Discord bot. I have a Discord bot, yes. That, hey, there's an upgrade here because this guy has been upgraded on this repository for whatever reason. And then I can just come in here and say, hey, that's great. Do it. And because I clicked on this, now it's going to be updated on my Git repository. My Git repository is going to be pulled by my Kubernetes cluster. My Kubernetes cluster is going to see the difference of my deployment, and it's going to get a new revision of my application. So lots to do, but the power of it is great. How do we check
There's
this?
another question. Okay, there. Yeah.
Yeah. For all pods in a container to identify the topmost pod consumption. So the utilization is exposed by every single node has to run what we call a container runtime interface. So that can be Docker, that can be containerd, whatever, and those expose the metrics endpoint. The metrics endpoint is what gives us this, right? That tells us, hey, this is the CPU and memory, and also you can have that exposed into a endpoint.
Oop. We lost you.
Can you hear me?
Now we can, yeah.
Okay, sorry. So yeah, and that is, it can be exposed to something like Prometheus, so you can scrape those metrics and then you can build something of that. If you don't expose that to something like Prometheus, this is going to be just ephemeral data that you can check right on time. So I can give you an example maybe. Let's see, Grafana. There we go. So this is what I mean. So you can apply whatever you want, right? So let's say I have my Flux 2, and then you can have things like that, right? You can have graphs now using Prometheus that just scrapes the metrics and then just, do everything that you want. So let's see. And this is my cluster, right? And you can see I have the CPU by namespace. By the way, this runs in the cluster as well. So all that you see here, my authentication layer, my GitLab, my dashboards, my alerts, everything runs local. So I'm not doing anything in the cloud. This is my own cloud. And then you can see how cool that is. And then you can, anyways, you guys have seen this, right? This is how it goes. And you're probably asking, hey, Guy, it's probably a daunting task to keep everything up to date. No, not really. I can also have something called cured that also checks and sees if my nodes need an upgrade. And what it does, it just says, hey, this operational system is out of date. I need to patch and upgrade. I am going to go and install the upgrades, remove all of the containers and move to the other nodes, upgrade this container, reboot, put it back into the cluster, and then balance everything out again. So it's just going to move. And when I say move, delete the pods from one node and put it in another. And I know that things are going to be always up to date. I don't have to worry about that as well. It's all kind of automated, right? Yeah. I hope this gives you an idea.
We have to thank Cassie for keeping you on your toes and helping you walk through all of this. I think they were pretty insightful questions.
Yeah. Thank you.
If there isn't anything else, I think I would ask to please complete that survey that I posted. It really helps us kind of shape what type of content we put out. Otherwise, thank you everyone for attending.
Ricardo, sorry, yes. I think there is one last question on the chat.
Oh, okay.
Are these upgrading packed running application? Not really. So let me show you this, Kazi. Great question. Sorry. Real quick. Let's see my Disco. Yeah, there we go. So the way that it works, see, it's running for 2 minutes here, my Discord upgrade. So because I am doing an upgrade that is doing a rolling upgrade, it's going to get a new one, wait for the new one to be available, and then once it is, switch the load balancer and then get rid of the old one. So it is kind of a hot reload of your application in the cluster. Hope that explains it. And it's all part of the deployment / ingress / service operators. There's a little bit more to that, but I guess you understand that. Mm-hmm. Yeah, again, Kazi, great question. Thank you. Yeah, anytime. And if you guys want, I'm going to plug this here. I'm sorry, guys. Just check it out my YouTube later. I'm trying to explain to depth those concepts as well. It's not going to get you to run your own Kubernetes. fully just in one video or two, but hopefully some of those concepts are going to be a little bit easier to understand. So when you come to talk to us and you need our help, you at least you're going to be more empowered to do some of those things, right? So that's the idea that I have here, right? But thank you, appreciate it.
Yeah, perfect. Thank you everyone for attending the event. If no more questions, I will stop the meeting. I think someone's just typing something on the message, just saying thank you. Yeah, we thank you everyone as well. Have a great afternoon and the rest of your day. Thank you, Gui. Thank you, Ricardo.
Thank you.
Thank you, Giselle. Bye.